If there is one question capable of making even the most experienced astronomers feel small, it is not whether life exists on other planets, nor whether black holes hide secrets we have yet to uncover. It is a far simpler question, at least on the surface. A question so deceptively straightforward that most people assume there must be a straightforward answer waiting somewhere in a textbook. The question is this: how many galaxies exist in the universe? At first glance, it sounds like the kind of thing scientists should already know. After all, humanity has built telescopes powerful enough to peer billions of light years into space. We have landed robots on other planets, sent probes beyond the outer boundaries of our solar system, and developed technologies capable of detecting worlds orbiting distant stars. Surely, if we can accomplish all of that, counting galaxies should be relatively simple. Yet the moment we begin examining the problem closely, something remarkable happens. The question itself starts to expand. What initially appeared to be a simple numerical mystery slowly transforms into a journey through some of the largest scales imaginable, forcing us to confront a reality so vast that the human brain struggles to process it. The truth is that when you look up at the night sky, you are seeing only a tiny fraction of what actually exists. On a perfectly dark night, far away from city lights, the average person can see several thousand stars. To ancient civilizations, those stars represented the entire cosmos. The sky appeared immense, mysterious, and endless. People built religions around it. They created myths to explain it. They navigated oceans using it. For thousands of years, humanity believed that those glowing points above our heads represented the universe itself. Even after the invention of the telescope, our understanding remained surprisingly limited. As astronomers peered deeper into space, they noticed faint cloudy objects scattered across the darkness. Some appeared as smudges of light, barely visible through early instruments. Nobody knew exactly what they were. Some scientists believed they were enormous clouds of gas located within our own galaxy. Others suspected something much larger, but there was no way to prove it. What makes this period of history so fascinating is that humanity was standing on the edge of one of the greatest discoveries ever made without realizing it. We were like explorers standing on the shore of a vast ocean while believing we were looking at a lake. Then came the 20th century, and with it a discovery that completely shattered humanity's perception of the cosmos. An astronomer named Edwin Hubble began studying one of those mysterious fuzzy objects known as Andromeda. At the time, many scientists referred to it as a nebula because they believed it was simply another cloud of material located somewhere inside the Milky Way. But as Hubble examined it more closely, he discovered something extraordinary. By measuring specific stars within that object and calculating their distance, he found that Andromeda was far too distant to belong to our galaxy. The implications were staggering. Andromeda was not a cloud inside the Milky Way. It was an entirely separate galaxy. Suddenly, the universe became unimaginably larger. The Milky Way was no longer the entire cosmos. It was merely one island floating within a cosmic ocean filled with countless other islands. Everything humanity had believed about the scale of existence changed almost overnight. Imagine standing on a beach your entire life believing that your island is the only landmass in existence, only to discover that beyond the horizon lie countless continents stretching farther than you could ever travel. That is essentially what happened to astronomy. As telescopes improved throughout the decades that followed, scientists discovered more and more galaxies. Some were beautiful spiral structures similar to our own Milky Way, their arms wrapping elegantly around bright central cores. Others appeared as giant elliptical collections, containing trillions of stars packed together in enormous glowing spheres. Some look distorted and chaotic, twisted by gravitational encounters with neighbouring galaxies. Everywhere astronomers looked, they found more galaxies waiting to be catalogued. Yet something even more astonishing was beginning to emerge. The deeper we looked into space, the farther back in time we travelled. This is one of the strangest concepts in astronomy. Because light moves at a finite speed, every object we observe is being seen as it existed in the past. When you look at the moon, you see it as it was about 1 second ago. When you look at the sun, you see it as it was roughly 8 minutes ago. When astronomers observe galaxies millions or billions of light years away, they are literally looking into the distant past, seeing those galaxies as they existed long before human civilization even began. The universe, in a sense, becomes a giant time machine, and the farther our telescopes could see, the more galaxies appeared. By the late 20th century, astronomers already knew that the universe contained staggering numbers of galaxies. But nobody was prepared for what would happen when one of the most famous scientific instruments ever built began sending data back to Earth. In 1990, the Hubble Space Telescope was launched into orbit above Earth's atmosphere. Free from the distortions caused by air and weather, it provided a level of clarity that ground-based observatories struggled to achieve. Over the years, Hubble would capture images that became iconic symbols of modern astronomy, revealing star nurseries, exploding stars, distant galaxies, and cosmic structures of breathtaking beauty. However, one particular experiment would forever change our understanding of the universe. Scientists selected a tiny patch of sky that appeared almost completely empty. There were no bright stars, no obvious galaxies. Nothing especially interesting seemed to exist in that region. To the naked eye, it looked like a patch of darkness. Then Hubble stared at that darkness for days. Instead of taking a quick photograph, it collected every faint particle of light arriving from that tiny area of space. Hour after hour, day after day, it continued gathering information from what seemed like nothing. When the final image was assembled, astronomers were stunned. The empty darkness was not empty at all. It contained thousands upon thousands of galaxies. Every small point of light visible in the image represented an entire galaxy. Each galaxy contained millions, billions, or even trillions of stars. Entire cosmic civilizations of stars had been hiding inside a region of sky so small that if you held a grain of sand at arm's length, it could cover the area Hubble had photographed. For many scientists, it was one of the most humbling moments in the history of astronomy, because suddenly a terrifying realization emerged. If thousands of galaxies existed within a tiny patch of darkness that appeared empty, then how many galaxies must exist across the entire observable universe? That question would lead researchers down a path of calculations, observations, and discoveries that continue to reshape our understanding even today. And the answer they eventually reached was so enormous that it forced scientists to rethink not only the scale of the cosmos, but humanity's place within it. As astronomers continued studying the results of the Hubble Deep Field and later observations that pushed even farther into the darkness of space, a strange realization began to emerge. The universe was not simply larger than expected. It was larger on a scale that seemed almost impossible to comprehend. Every improvement in telescope technology revealed more galaxies hiding in the distance, and every new survey suggested that the cosmic inventory was far from complete. For many years, scientists estimated that the observable universe contained roughly 100 billion galaxies. That number alone was enough to overwhelm the imagination. After all, the Milky Way itself contains hundreds of billions of stars, which means that even under the most conservative estimate, the observable universe would contain numbers of stars so large that writing them down would require more digits than most people have ever encountered in their lives. Yet as researchers refined their methods and examined deeper observations from Hubble, they began to suspect that something was wrong with those estimates. The problem was not that astronomers were counting incorrectly. The problem was that many galaxies were simply too faint and too distant to detect. Imagine standing on a mountain at night and looking toward a distant city. The brightest buildings would be easy to see, while smaller lights might fade into the darkness. Now imagine moving that city thousands of times farther away. Eventually, only the brightest lights would remain visible, even though countless others still existed beyond your ability to detect them. The universe presents astronomers with a similar challenge. The farther away a galaxy is, the fainter it appears, and many ancient galaxies are so distant that even our most advanced instruments struggle to observe them. As researchers attempted to compensate for these missing galaxies using mathematical models and observational data, they arrived at a startling conclusion. The true number of galaxies in the observable universe might not be 100 billion at all. Instead, some studies suggested that the actual figure could exceed 2 trillion galaxies. To appreciate how astonishing that number is, it helps to slow down and consider what it actually means. Most people have difficulty visualizing 1,000,000 of anything. 1 billion already feels abstract. 1 trillion exists so far beyond ordinary human experience that our brains tend to treat it as just another large number. But the difference between 1 billion and 1 trillion is enormous. If you counted one number every second without sleeping, it would take you more than 30 years to reach 1 billion. To count to 1 trillion under the same conditions would take over 30,000 years. Now imagine not 1 trillion stars. Imagine 2 trillion galaxies, each galaxy potentially containing hundreds of billions of stars. At that point, the numbers begin escaping the limits of intuition entirely. Yet even this extraordinary estimate comes with an important limitation. Scientists are not talking about the entire universe. They are talking only about the observable universe, which is a very different thing. This distinction is crucial because many people hear the phrase observable universe and assume it refers to everything that exists. In reality, it refers only to the portion of the universe from which light has had enough time to reach us since the beginning of cosmic history. To understand why this matters, imagine standing in the middle of a vast desert during a foggy morning. You can only see as far as the fog allows. Beyond that boundary, more desert almost certainly exists, but it remains hidden from view. The observable universe functions in a somewhat similar way. Because the universe is approximately 13.8 billion years old, and because light travels at a finite speed, there is a limit to how far we can see. Beyond that horizon may lie countless additional galaxies, perhaps infinitely many, but their light has not yet had enough time to reach us. This creates one of the strangest situations in all of science. We can estimate the number of galaxies within the observable universe, but we do not actually know how large the entire universe is. It could be vastly larger than the observable region. It could contain numbers of galaxies that make even the estimate of 2 trillion seem insignificant by comparison. Some cosmological models even allow for the possibility that the universe may be infinite, stretching beyond any conceivable boundary. If that idea sounds difficult to grasp, it is because it truly is. Human beings evolved to understand forests, rivers, mountains, and distances measured in kilometers. We did not evolve to comprehend structures measured in billions of light years. Our intuition breaks down completely when confronted with scales this large. Yet the universe does not care about the limitations of human intuition. It simply exists as it is, whether we find it comprehensible or not. What makes the story even more fascinating is that galaxies themselves are not distributed randomly throughout space. They gather into enormous structures called galaxy clusters, where hundreds or even thousands of galaxies are bound together by gravity. These clusters, in turn, connect to other clusters through immense cosmic filaments stretching across unimaginable distances. When astronomers map these structures on the larger scales, the universe begins to resemble a gigantic cosmic web. The image is both beautiful and unsettling. Instead of isolated islands floating in emptiness, galaxies form part of a vast interconnected network extending across the observable cosmos. Between these filaments lie enormous voids, regions so empty that a traveller crossing them would encounter almost nothing for hundreds of millions of light years. These voids are among the largest structures known to exist, reminding us once again that emptiness itself can reach scales beyond ordinary comprehension. And somewhere within one small spiral galaxy, located in one tiny corner of this cosmic web, exists our solar system. Around one ordinary star orbit a handful of planets. On one of those planets, a species emerged that became capable of asking questions about the universe that created it. When viewed from this perspective, humanity appears unimaginably small. Yet there is another way to interpret the same facts. The fact that a collection of atoms on a small rocky world can study galaxies billions of light years away may be one of the most remarkable achievements in cosmic history. The universe has produced beings capable of observing itself. And as our technology continues advancing, our understanding of galaxies continues changing. New telescopes have begun revealing objects so distant that their light started travelling toward us when the universe was still in its infancy. Some of these discoveries are creating new puzzles for astronomers because certain galaxies appear larger, brighter, and more developed than current theories predicted. Instead of simplifying our understanding of the cosmos, each breakthrough seems to uncover deeper mysteries waiting beneath the surface. The more we learn about galaxies, the more we realize how much remains unknown. Every answer leads to new questions. Every discovery reveals new uncertainties. And nowhere has this become more apparent than in the era of the most powerful space telescope humanity has ever built, an instrument capable of looking farther into the past than any telescope before it, and revealing galaxies that existed near the dawn of time itself. What made the arrival of the James Webb Space Telescope so exciting was not simply the fact that it was more powerful than Hubble. Humanity had built larger telescopes before. We had developed better cameras before. We had improved our instruments countless times throughout history. What made James Webb different was that astronomers believed it might finally allow us to see some of the earliest galaxies ever formed, pushing our view closer to the beginning of cosmic history than anyone had thought possible. When the first images began arriving, the scientific community quickly realized that they were looking at something extraordinary. Objects that appeared as faint smudges in older observations suddenly revealed structure and detail. Galaxies that had previously been invisible emerged from the darkness. Regions of the universe that had seemed empty became crowded with ancient cosmic systems stretching far into the distance. Yet alongside the excitement came something unexpected: confusion. Because some of the galaxies Webb discovered did not behave the way astronomers expected them to behave. According to our current understanding of cosmic evolution, the early universe should have been relatively simple. Following the Big Bang, matter gradually began gathering together under the influence of gravity. Small structures formed first. Larger structures emerged later. Galaxies were expected to grow over long periods of time as stars formed and systems merged together. In other words, astronomers expected the earliest galaxies to appear small, primitive, and relatively undeveloped. Instead, Webb began finding galaxies that appeared surprisingly large and surprisingly mature for their age. Some seemed to contain enormous numbers of stars, despite existing at a time when the universe was still extremely young. Others appeared brighter than expected. Every new observation forced researchers to ask difficult questions about whether parts of their models might be incomplete. This is one of the most fascinating aspects of science that many people never fully appreciate. Scientific progress does not happen because scientists are always correct. It happens because they are willing to challenge their own assumptions whenever new evidence appears. The greatest discoveries often emerge not when observations confirm existing theories, but when observations refuse to cooperate with them. And nowhere is that more apparent than in our attempts to understand galaxies. Because when we observe galaxies, we are not merely counting them. We are attempting to reconstruct the history of the universe itself. Every galaxy is a kind of fossil record, preserving clues about conditions that existed billions of years ago. By studying their shapes, compositions, motions, and distributions, astronomers can piece together an enormous cosmic story stretching across almost 14 billion years. One of the strangest discoveries to emerge from this effort involves something that nobody has ever directly seen: dark matter. The story begins with a simple observation. When astronomers measured the speeds at which stars orbit within galaxies, the numbers did not make sense. According to the amount of visible matter present, stars near the outer regions of galaxies should have been moving much more slowly than they actually were. Yet observation after observation revealed the same pattern. Galaxies appeared to contain far more mass than could be accounted for by their stars, gas, dust, and planets. At first, scientists assumed there must be mistakes in the measurements. Perhaps the calculations were wrong. Perhaps certain effects had been overlooked. But as the evidence accumulated over decades, a more radical possibility emerged. Most of the matter in galaxies might be invisible. Today, the leading explanation is that galaxies are embedded within enormous halos of dark matter, a mysterious substance that does not emit light, reflect light, or interact with ordinary matter in ways we can easily detect. We cannot see it directly, yet its gravitational influence appears everywhere. Without dark matter, many galaxies would not behave the way they do. Without dark matter, the large-scale structure of the universe itself becomes difficult to explain. This realization adds another layer of mystery to the question of how many galaxies exist. Not only are galaxies unimaginably numerous, but much of what holds them together remains poorly understood. Humanity has spent centuries studying the cosmos, and yet one of the primary ingredients shaping the universe is still largely unknown. The deeper astronomers investigate, the stranger reality becomes. Then there is the question of what happens when galaxies interact with one another. Many people imagine galaxies as isolated systems peacefully floating through space, but the universe is far more dynamic than that. Galaxies frequently encounter one another, pass near one another, and sometimes collide in events so enormous that they dwarf anything occurring on smaller scales. The word collision can be misleading because galaxies are mostly empty space. Individual stars rarely crash directly into each other. Instead, gravity slowly reshapes entire galactic systems over millions or even billions of years. Spiral arms become distorted, streams of stars are pulled outward, massive clouds of gas collapse, triggering waves of new star formation. In some cases, two galaxies merge completely, creating a larger galaxy from their combined material. This process has occurred throughout cosmic history and continues today. In fact, our own Milky Way is heading toward one of the most famous galactic collisions ever discovered. Astronomers have determined that the Milky Way and the Andromeda galaxy are moving toward each other and will eventually merge. Fortunately, this event remains billions of years in the future, far beyond any timescale relevant to human civilization. Nevertheless, it serves as a reminder that galaxies are not static monuments frozen in time. They are living systems constantly evolving under the influence of gravity. When that future merger finally occurs, the night sky of any surviving planets would become almost unimaginable. Massive streams of stars would stretch across the heavens. The structure of both galaxies would gradually dissolve and reform. Entire constellations would change. The cosmic environment familiar to humanity today would disappear forever. And yet, even events on that scale represent only tiny chapters within the larger history of the universe. Because while galaxies are born, grow, interact, and sometimes merge, the universe itself continues expanding. Every second, the distances between distant galaxies increase. Every moment, space stretches a little more. Galaxies located far beyond our local cosmic neighborhood are moving away from us, not because they are flying through space like rockets, but because space itself is expanding between us. This expansion creates one of the most profound consequences in all of cosmology. There are galaxies whose light will never reach us. There are regions of the universe so distant that the ongoing expansion of space prevents their future light from ever crossing the enormous gulf separating us. No matter how advanced our telescopes become, some parts of reality may remain permanently beyond our reach. That idea carries a strange emotional weight. The observable universe already contains numbers so large that they challenge comprehension. Yet even that vast cosmic domain may represent only a fraction of what actually exists. Beyond the limits of observation could lie additional galaxies, additional clusters, additional structures, and perhaps entire regions of reality that humanity will never directly see. And when scientists combine these possibilities with the latest observations from modern telescopes, the original question begins to transform into something far more profound than a simple counting exercise. The question is no longer merely how many galaxies exist. The question becomes whether the true scale of the cosmos is something the human mind can ever fully understand. As researchers push deeper into the question of how many galaxies exist, they eventually encountered a realization that was perhaps even more unsettling than the enormous numbers themselves. The realization was that humanity may never know the final answer with complete certainty. This is not because scientists lack intelligence, nor because technology will eventually fail, but because the universe imposes fundamental limits on what can be observed. Most people imagine scientific progress as a straight line leading steadily toward complete understanding. They picture a future in which every mystery is solved and every question receives a definitive answer. Yet cosmology often teaches the opposite lesson. The more we learn about the universe, the more we discover that reality is far larger, stranger, and more complex than our original questions assumed. To understand why the number of galaxies may never be known exactly, we must return to the concept of the observable universe. When astronomers say that the observable universe stretches approximately 46 billion light-years in every direction, many people find the statement confusing. After all, if the universe is around 13.8 billion years old and light travels at a finite speed, shouldn't the observable edge be only 13.8 billion light-years away? The answer lies in the fact that the universe has been expanding throughout cosmic history. While light was travelling toward us for billions of years, the space through which it travelled continued stretching. As a result, the objects that emitted that light are now much farther away than they were when the journey began. This means that the observable universe is vastly larger than many people initially imagine. Yet beyond that observable boundary lies a region that remains inaccessible. We can develop theories about it. We can create mathematical models describing it. We can estimate its properties based on what we observe nearby. But we cannot directly see it. And this introduces a fascinating possibility. Imagine for a moment that the observable universe contains roughly 2 trillion galaxies. Even that number is almost impossible to comprehend. Yet if the universe extends far beyond the observable horizon, then there may be countless additional galaxies existing forever beyond our view. There may be galaxy clusters larger than anything we have ever detected. There may be structures spanning distances so enormous that our current understanding barely scratches their surface. Some cosmologists believe that the observable universe may represent only a tiny fraction of the whole. Others suggest that the total universe could be incomprehensibly larger than anything we can currently imagine. Certain models even allow for the possibility that space extends infinitely in every direction. The word infinite is easy to say, but its implications are astonishing. An infinite universe would mean that the number of galaxies is not merely large. It would mean there is no final number at all, no ultimate total waiting to be discovered, no cosmic inventory that could ever be completed. Human beings naturally seek boundaries because boundaries make reality easier to understand. We like beginnings and endings. We like knowing where things start and where they stop. Yet the universe repeatedly challenges those instincts. Every time humanity believed it had discovered the edge of existence, a larger horizon appeared beyond it. Ancient civilizations thought their cities represented the center of the world. Later generations learned that Earth was only one planet orbiting an ordinary star. Then we discovered that our Sun was only one star among hundreds of billions within the Milky Way. Then we learned that the Milky Way itself was only one galaxy among countless others scattered throughout the cosmos. Each discovery delivered the same message. Reality was larger than we thought. Then reality turned out to be larger still. And perhaps the most humbling aspect of this story is that humanity has made these discoveries within an incredibly short period of time. The entire scientific understanding of galaxies is remarkably recent. For nearly all of human history, nobody knew they existed. The realization that other galaxies populate the universe emerged only within the last century, which means that we are still in the earlier stages of understanding the larger cosmic environment around us. If a person living in the year 1920 suddenly appeared today and learned that astronomers routinely study galaxies billions of light years away, map giant cosmic structures spanning hundreds of millions of light years, and analyze light that began its journey before Earth even formed, they would likely view such achievements as impossible. Yet from our perspective, these discoveries have become part of normal scientific knowledge. This raises an intriguing question. If our understanding has changed so dramatically in just one century, what might humanity learn during the next 100 years? Future telescopes will almost certainly surpass the capabilities of both Hubble and James Webb. New instruments may reveal populations of galaxies that remain invisible today. They may uncover details about the earliest moments of galaxy formation. They may help solve the mystery of dark matter. They may even force scientists to revise major portions of existing cosmological theories. History suggests that every generation believes it possesses a reasonably accurate picture of the universe, only to discover that the next generation sees much farther. The universe seems determined to remain one step ahead of our expectations. And perhaps that is what makes the question of galaxies so captivating. On the surface, it appears to be a question about numbers. People hear the phrase, "How many galaxies exist?" and expect an answer similar to counting countries on Earth or planets within a solar system. Yet the deeper we investigate, the more we realize that the question touches something much larger. It forces us to confront scale. It forces us to confront time. It forces us to confront the limits of observation. And ultimately, it forces us to confront our own place within reality. Because every galaxy we observe contains countless stars. Around many of those stars orbit planets. Around some of those planets, conditions may exist that resemble those of Earth. When astronomers discuss trillions of galaxies, they are indirectly discussing possibilities so vast that even estimating them becomes difficult. Somewhere within that immense cosmic ocean, other worlds may exist beneath alien skies. Other civilizations may be asking questions about the universe. Other observers may be staring into the darkness and wondering how many galaxies surround them. Whether those possibilities are real remains unknown, but the sheer number of galaxies dramatically changes how we think about them. The larger the universe becomes, the more room there is for possibilities beyond our current imagination. And this is where the story begins to move beyond astronomy and into philosophy. Because the question is no longer merely about what exists, it becomes a question about perspective. Human beings spend much of their lives worrying about problems that seem overwhelming in the moment. We become consumed by deadlines, conflicts, disappointments, and fears. Yet when we step back and consider a universe potentially containing trillions of galaxies, each filled with unimaginable numbers of stars, something curious happens. Our perspective changes. The problems do not disappear, but they become smaller relative to the larger picture. For centuries, philosophers and astronomers alike have described the night sky as a source of humility, not because it diminishes humanity, but because it reminds us that we are participants in something far greater than ourselves. The same universe that created galaxies also created stars. The same stars forged the elements necessary for planets. And from those elements eventually emerged life capable of wondering where it came from. The story of galaxies is therefore not merely a story about distant objects scattered across space. It is also, in a strange and beautiful way, a story about us. What makes this realization even more remarkable is that after everything we have discussed, after the trillions of galaxies, the unimaginable distances, the ancient light traveling across billions of years, and the possibility that the universe extends far beyond anything we will ever observe, we still find ourselves returning to the same simple question that has fascinated humanity for generations. What does all of this actually mean? The scientific answer is straightforward. Galaxies are the building blocks of the large-scale universe. They are enormous gravitational systems that formed over billions of years through processes that scientists continue to study. They contain stars, planets, black holes, gas, dust, and the mysterious dark matter that appears to shape much of cosmic structure. Their existence helps us understand how the universe evolved from a hot and dense beginning into the vast cosmic landscape we see today. Yet for many people, that answer feels incomplete, because the moment we truly begin to grasp the scale involved, something changes inside us. The universe stops feeling like a collection of scientific facts and starts feeling like a profound mystery. We begin to realize that every galaxy visible through a telescope is not simply an object. It is an entire realm. It is a place where stars are born and die. It is a place where planets form. It is a place where unimaginable events unfold over timescales so vast that entire civilizations could rise and disappear before a single galactic orbit is completed. Our own Milky Way is one such realm. Inside it are hundreds of billions of stars. Around many of those stars orbit planets. Somewhere among those countless worlds exists a small blue planet circling an ordinary star in an ordinary region of an ordinary galaxy. Upon that planet, a species emerged that developed language, curiosity, mathematics, science, and imagination. A species that learned how to build telescopes and point them toward the heavens. A species that began asking questions no other known life form has ever asked. That fact alone is astonishing, because when we speak about the universe, we often focus on how small humanity is. We compare ourselves to galaxies and clusters and cosmic structures stretching across billions of light years. We emphasize our insignificance against the backdrop of the cosmos. And while there is truth in that perspective, there is another side to the story that is equally important. The universe may be vast beyond comprehension, but as far as we currently know, humanity represents one of the few places where the universe has become aware of itself. Every telescope ever built, every equation ever written, every observation ever recorded is part of a process through which the cosmos is examining its own nature. The atoms inside our bodies were forged inside ancient stars that died long before Earth existed. The elements that make up our bones, our blood, and our brains were created in cosmic events that occurred billions of years ago. In a very real sense, we are products of the universe attempting to understand the universe, and perhaps that is why questions like this continue to captivate us. Because the search for the number of galaxies is not merely an attempt to count objects. It is an attempt to understand the environment that produced us. It is an attempt to locate ourselves within a reality so enormous that every answer seems to reveal an even larger mystery waiting beyond it. Today, the best estimates suggest that the observable universe contains trillions of galaxies. Tomorrow, new discoveries may force us to revise those numbers once again. Future telescopes may uncover galaxies so distant that they challenge our current theories. New observations may reveal structures we have never imagined. Entire chapters of cosmic history may still be waiting in the darkness beyond our present reach. And that is perhaps the most exciting part of all. The story is not finished. Humanity has not reached the end of its journey through the cosmos. We are still living during the opening chapters. We are still learning the basic outlines of the universe's history. We are still discovering how galaxies formed, how dark matter shapes reality, how cosmic structures evolved, and whether life exists elsewhere among the countless stars scattered across the heavens. Somewhere beyond the reach of our most powerful instruments, there are galaxies whose light has not yet arrived. There are events unfolding right now that humanity will never witness. There are regions of reality hidden behind the limits imposed by space, time, and the speed of light itself. Yet despite those limits, we continue searching. We continue building larger telescopes. We continue asking bigger questions. We continue pushing farther into the darkness. And perhaps that relentless curiosity is one of the most extraordinary things about our species. Because when faced with a universe so vast that it threatens to overwhelm comprehension, humanity did not look away. Instead, it chose to investigate. It chose to measure. It chose to calculate. It chose to wonder. So the next time you step outside on a clear night and look toward the stars, remember that the tiny points of light visible above your head represent only the smallest glimpse of a reality far greater than the eye can see. Beyond those stars lies the Milky Way. Beyond the Milky Way lie neighbouring galaxies. Beyond those galaxies lie trillions more scattered throughout the observable universe. And beyond the observable universe may lie realms so vast that even our most ambitious imaginations fall short of describing them. The terrifying truth about how many galaxies exist in the universe is that the number is already almost beyond human comprehension, and yet the real truth may be even more astonishing. We may never discover a final answer, because every generation that looks deeper into the cosmos seems to find that reality is larger than anyone expected. And perhaps that is the greatest lesson the universe has to offer. No matter how much we learn, there will always be another horizon waiting in the distance, another mystery hidden beyond the edge of our knowledge, and another question inviting us to continue the journey. The universe is not merely bigger than we imagine. It may be bigger than we are capable of imagining.